All right, we're moving on to lesson 7-3, proving triangles similar. Now, the previous chapter we were proving triangles congruent, and the way you would prove two different triangles to be the same size and same shape, there would have been three congruent tick marks on the side, 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 or a side, an angle, and a side, side, angle, angle, side, or hypotenuse leg. And then if any of these scenarios, tick marks occurring in this fashion, you would be able to say that the two triangles are congruent. Well, we're moving on to, well, how about proving two triangles similar? And there's going to be three postulates instead of the five that you have listed here. There is going to be angle-angle similarity, AA with a little squiggle, that means similarity, side-angle-side similarity, and side-side-side similarity with the little squiggle behind it. When you have angle similarity, basically all you have to have is two congruent angles, and you're basically saying these two triangles are similar. Okay? Again, we're not saying congruent because you can tell this guy's bigger, but we are saying similar. And it's the angles that create the shape of the triangle. All right? And also, if you remember, if you have two congruent angles, you really have three congruent angles, but that's not necessarily. That is a way to prove that they are similar. Here's another one. Side angle side similarity. Now we've got two triangles here, one big one here, one small one here. Because of vertical angles, there's a tick mark here and a tick mark here, so we have congruent angles in the middle. And we are not saying when we say SAS, and we say the S, I'm not going to put a tick mark on this 18 and a tick mark on this 36. Obviously those are two different numbers. But what we are saying is that the sides, the two S's, are in equal proportion. Like 18 on the small matches up with 36 on the big, 12 on the small matches up with 24 on the big, and these are in equal proportion. This is 1/2, this is 1/2. And so the side lengths, and I'm not going to put tick marks here because they're not the same length, but you can tell I do have a side of equal proportion, an angle, and then the same another side of that same equal proportion of 1/2. That is side angle side similarity. And finally, there is side 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 similarity. You are not putting tick marks anywhere, but 8 to 6 is the same as 8 to 6, which is, of course, those are the same, which is the same as 12 to 9. If I reduce this, this is 4/3, this is 4/3, this is 4/3 as well. They all reduce to the same ratio, similarity ratio, 4 to 3, 4 to 3. And if all three sides grow or shrink at the same rate, they are similar. Moving on to actual calculations here, let's try number 1 here. In the sunlight, a cactus casts a 9-foot shadow. At the same time, a person who's 6 feet tall casts a 4-foot shadow. Using similar triangles, find the height of the cactus here. So that's where the X is. It's the height of this cactus. Now, nobody's going to climb up a cactus to figure out how tall it is. But if there is a sun out here shooting down rays, it will create two similar triangles. From the head down here, this is a yellow triangle, cactus height, the shadow here, and then the ray of the sunlight. Those are the two yellow similar triangles. And so what we're going to say here is the sunlight is creating the same effect. You should be able to figure out the height of this cactus by simply going 6 feet on the guy is like X on the cactus, the height of the cactus. 4 feet is the shadow of the guy on the ground. 9 feet is the shadow of the cactus. So height to height, shadow to shadow. And then once you have that, you would simply cross multiply this to solve. This is 4x is equal to, what is that, 54. X is equal to 13.5. I hope that's correct. 13.5x. So the cactus is 13.5x based on this setting up of a proportion.